Hi everyone, this is Mrs. G, and today we're going to be solving radical equations, but first please pause the video and give this warm-up a try. Alright, go ahead and check here. So this is solving quadratics using the square root method. So a little review, we isolate our x squared term and then we take the plus or minus square root of both sides and simplify if possible. So for part A, our answer is just plus or minus root 6. For part B, we end up with plus or minus square root of negative 8, which remember gives us I root 8. So this is an imaginary number. And then we can also simplify square root of 8. So we get plus or minus 2I root 2. So the reason why we did this in the warm-up is because this general process of isolating and then undoing the square is very similar to what we're going to be doing today when we're solving radical equations. So to solve a radical equation, which is an equation that contains radicals that have variables on the inside in the radicands, first we isolate the radical, just like in the warm-up how we isolated the x squared term. Then we're going to raise each side of the equation to the power that matches the index. So if it's a square root, we're going to square both sides. If it's a cube root, we're going to cube both sides, so on and so forth. And then we're going to finish solving for x. Now for these, it is really important that we check our solutions because sometimes with our square root equations, we end up with what are called extraneous solutions. So we didn't do anything wrong when we were solving. Algebraically, our steps were valid, but they're simply not solutions because square root functions have domain restrictions. So what you need to do, and we're going to do this for both square roots and cube roots, when we have our solutions, we're going to substitute them into the original equation to make sure that we get a true statement. So for every single problem, for every single solution, we will check our solutions. All right, let's look at this first one together. So remember, our first goal is going to be to isolate our radical, the square root term. So I'm going to start by subtracting 3 from both sides. So 2 times the square root of x plus 1 equals 4. And then I'm going to divide both sides by 2. So I have the square root of x plus 1 equals 2. And now that it's isolated, the way that I can undo the square root is by squaring both sides. So that leaves me with x plus 1 equals 4. Now all I need to do is finish solving, so I'm going to subtract 1 from both sides, and I get x equals 3. But before I box my answer, I am going to check with substitution into the original problem, and I do need to see every step of your double check. So we do 2 times the square root of 3, that's what I'm substituting for x, plus 1, plus 3 equals 7. So please start with just a substitution step. From there we can start simplifying. So 2 times the square root of 4 plus 3 equals 7. And also when we're checking, we should not be moving things from one side to the other. We're simply simplifying one side at a time until we can show that the left side equals the right side. So here we see that the square root of 4 is 2. And then we have 4 plus 3. So we get 7 equals 7. So without moving anything from one side to the other, we've substituted x equals 3, and we've shown that the left side equals the right side, which means that this is a valid solution. All right, let's try another one together. So here you can see we have a cube root equation. So again, our first step is going to be to isolate our radical. So I can do that by adding 1 to both sides. So we have the cube root of 2x minus 9 equals negative 3. And then to undo a cube root, we're going to cube both sides. So this power should match the exponent, or the index. So that leaves us with 2x minus 9 equals negative 27. Remember, if you're cubing a negative, the result should be a negative. From here, I am going to add 9 to both sides to finish solving. So 2x equals negative 18. and then I can divide both sides by 2. So I get x equals negative 9. But again, before I box my solution, I am going to check with substitution. So I have the cube root of 2 times negative 9 minus 9, and then minus 1 equals negative 4. So don't add 1 to both sides. We keep everything on the side that it's on, and we just simplify. So here, 2 times negative 9 is negative 18 minus 9. So that's the cube root of negative 27 minus 1. The cube root of negative 27 is negative 3. And we see that negative 3 minus 1 is negative 4. So we have shown that the left side equals the right side when we substitute x equals negative 9, which again means that it is a valid solution. All right, I have one for you to try on your own, so please pause the video. All right, go ahead and check your work here. So in this problem, you can see how important it is that we have done our double check. So here we isolate our variable, or our radical, we square both sides and finish solving. We get x equals 7. We didn't do anything wrong algebraically, but when you substitute into the original equation and you simplify, you end up with the statement 1 equals negative 11, which is just not true. So that means that this is what's called an extraneous solution. And since it is our only possible solution and it doesn't work, that leaves us with no solution. So again, this does not mean we did anything wrong. It's because square root functions have domain restrictions. So sometimes an answer we get will not be part of the domain, and so that gives us a no solution problem. All right, I have one more for you to try on your own, so again, please pause the video and give it a shot. Let's go ahead and check your work here. So you isolate your cube root term, cube both sides, and finish solving. Before you box, make sure you substitute 65 into the original equation, and without moving anything from the left to the right side or vice versa, simplify and show that the left side equals the right side. And so 65 is a valid solution. All right, let's try another one together that's a little bit trickier. So here we can see that our square root term is already isolated. So we are going to go ahead and square both sides. But you'll notice that when I square both sides, when I did it previously, I put parentheses around it before I squared it. That's really important because when we do that for this problem, you have to square the entire side, which actually becomes x plus 1 times x plus 1. Remember, x plus 1 squared, we cannot distribute an exponent to a sum or difference. We have to FOIL out this binomial. So this problem is a little bit more involved. So if you multiply this out, we get x squared plus x plus 1. So x squared plus 2x plus 1. So you can see that now what we actually end up with is a quadratic equation. Luckily, we all know how to solve quadratic equations. I'm going to set my equation equal to 0. So I'm going to subtract 7x from both sides and subtract 15 from both sides. So we have x squared minus 5x minus 14 equals 0. And of course, if we can factor, that would be the method that I pick. And luckily it is factorable, so x minus 7 times x plus 2 equals 0. I would still like you to show that zero product property step. So we get x equals 7 and x equals negative 2. So now we have two answers that we need to check. And remember, when we check, we do it into our original equation. So let's start by checking x equals 7. So we have 7 plus 1 equals the square root of 7 times 7 plus 15. So 8 equals the square root of 49 plus 15. So 8 equals the square root of 64. 8 equals 8. that tells us that x equals 7 is a solution. And then we need to check x equals negative 2. So we have negative 2 plus 1 equals the square root of 7 times negative 2 plus 15. So here we get a negative 1 on the left side of our equation. So here we still get, we get negative 14 plus 15. So negative 1 equals the square root of 1. So the square root of 1, the positive square root of 1 is just 1. If they wanted the negative square root, it would already be there. If they wanted the plus or minus, it would be there. So you can see that when we substitute negative 2, we do not get a true statement, which means that x equals negative 2 is an extraneous solution. So we should not include it as part of our answer. All right, I have one for you to try on your own, so please pause the video and give it a shot. All right, go ahead and check your work here. So we are going to square both sides, and remembering we're squaring the entire side. So we have x minus 4 squared, which actually means this. So you can expand it out, giving you a quadratic. So that means we need to set our equation equal to 0. This one we can solve by factoring, and we get two potential solutions, which we need to check by substituting into our original equation. And when we do that, we find that x equals negative 1 is actually an extraneous solution. I do want to point out that while it is, fairly common to end up with two possible solutions and then one of them ends up being extraneous, it's also possible to have two solutions. So just because one works doesn't mean the other one won't. It is possible to have two solutions, one solution, or no solution when you're doing these types of problems. Okay, we're going to try one more problem together. I would definitely call this a challenge problem, but it's good to try hard problems sometimes. So here we have two radicals and an added constant. So it won't be possible for us to fully isolate both of them. So as long as one is fully isolated, we're still going to do our process of squaring both sides, and that's going to get rid of at least this radical. But on the left side, we have something that we do need to expand out. Now I know it looks really scary, but if you kind of just go one step at a time, we'll be fine. So when I multiply this term by this term, the square roots actually cancel out, and what we're left with is just x plus 2 with no radical. And then I have this times 1, so I have plus the square root of x plus 2, and then I have another one of those, plus the square root of x plus 2, and then I have 1 times 1, which is 1. And then you could see what I have here is the same radical being added twice. So I could say 2 times the square root of x plus 2, and then I have a plus x, and then plus 3 equals 3 minus x. So now I have a single radical, so I'm going to follow my process, and I'm going to isolate the radical and then square both sides again. So first, I'm going to subtract 3 from both sides and subtract x from both sides. So you could see that the 3's will actually cancel out here, and then we're left with negative 2x. Then I can divide both sides by 2. So we have square root of x plus 2 equals negative x, and then I'm going to square both sides to clear my radical. So I'm left with x plus 2 equals x squared. So when I square the negative will disappear. So here we have another quadratic equation. So I'm going to set my equation equal to 0. And this one we can also factor. So it multiplies to get negative 2 and adds to make negative 1, negative 2 and 1. So we have x minus 2 times x plus 1. So we get two possible solutions, positive 2 and negative 1, which we need to check. So first let's check x equals 2. So square root of 2 plus 2 plus 1 equals the square root of 3 minus 2. Square root of 4 plus 1 equals the square root of 1. And this gives us 2 plus 1 equals 1. So we're left with this statement, and we could see that, well, 3 does not equal 1, so that would give us an extraneous solution here. And then I'm going to check my other possible solution. So here we have the square root of -1 plus 2 plus 1 equals square root of 3 minus -1. So this gives me the square root of 1 plus 1 equals the square root of 4. And square root of 1 is just 1. So 1 plus 1 is 2, and the square root of 4 is 2. So this is a true statement, which tells us that -1 is our solution. So again, definitely a challenge problem, but it's good to be able to, try problems like this and still try to follow that same process. You'll see we just have to do 2 rounds of squaring both sides, and it's good to get this practice of, multiplying out more complex binomials as well. All right, here's your last U try. So another challenge problem, but let's see if you can do it on your own. All right, go ahead and check your work here. Again, this is definitely a challenge level problem, but if you were able to get through it and get the 2 potential answers of +3, -2, and then to realize that x equals 3 ends up being extraneous, awesome job. Make sure you do have your full double check shown out, showing that the left side equals the right side or the left side does not equal the right side. But yeah, this is definitely like the hardest type of problem you would come across for our class. All right, that is all for today's notes. Thank you so much for watching.